Now let's see the next algorithm, round robin algorithm. This is the most popular algorithm of all, and many of the operating systems at practice are using it because one thing is it is going to provide you various advantages like this. First thing is it is practically implementable because it is not depending on burst time, and second thing is it doesn't require lots of data structures like heap and all. Using a queue we can implement it. And then the next thing is the response time, or there is nothing called as starvation here. The reason is okay, I'll tell you how it works. I'll tell you how it works and then we should analyze it. So round robin works this way. It will take a particular process for execution and it will not execute it till completion, or it will not execute till next process arrives. Nothing like that. Whatever the process it is going to execute it only for some particular amount of time. That is called time quantum. And after executing that process for time quantum, whatever the process is, it will preempt it, and again the next process will get into the execution, and then it will get executed again for the time quantum. So every process will get executed only for small amount of time, which is called as time quantum, right? Therefore no process is going to wait forever for the CPU. So every process is going to get a chance after some amount of time, and every process will keep on getting the chance after some regular amounts of time. Therefore it is having very less starvation problem, and then it is very easy to implement, as I said. Now let's see the algorithm, and then I'll take an example and I'll explain you. Even if you didn't understand, even if you don't understand anything here when I'm teaching it, don't worry, example will make it really clear, and I'll solve lots of examples on this. Watch it. Now initially we will be in the ready state, and then we pick a process, we select a process. After selecting a process, we check this one, whether the burst time of the process is less than the time quantum required. So what is time quantum? That is the fixed amount of time we fixed, so that any process that we pick up will be executed only for that much amount of time. Now it is like every process will be given this much time, that is called time quantum. And now I'm saying that if burst time is less than time quantum, what does it mean? The process does not need this much amount of time which you are planning to give. You are planning to give TQ, time quantum, but then process doesn't require really this much amount of time. Then what you could do is you need not give it so much time, right? Then we will give it only the time which is required. It is like this, how can I say it? See, okay, I think you understood it, right? Okay, fine. So what I mean to say is, if you fixed up the time quantum, which means if you are willing to give 10 seconds, but then the process totally needs only 5 seconds, then why give it 10 seconds, right? That is the condition. So if the process requires less time than what you are willing to give it, then what it will do is it will execute till completion. In other case, if the process requires more time than which is allocated for it, then it will execute only for a time quantum amount of time. And after executing it, we shall check whether the process execution is completed. So process exe means execution completes. Since I don't have space below this, that is why I am writing it. I have written the diamond shape like this. It is not an arrow, it is diamond only. Diamond is a condition checking. So after running a process for time quantum, we are going to check whether the process is completed. In case if the process is completed, then I am going to terminate, right? So otherwise, if the process is not completed, which means if it requires more time, then again it has to go back into the ready state and wait there. I don't know if you really understood this. I'll take an example and this will be very clear. So what you do is you just note it down, and maybe after taking an example we shall come to this point. I mean, this will be, you can refer to this and it will be clear. Okay.